Up next, we have Matt Zucker talking about computer-assisted quilting.
Thank you, Isidore. I think I'm a better quilt designer than I am a quilt stand designer, so we're just going to hope that thing stands up for the rest of the performance. I'm Matt Zucker. I work not too far from here at Swarthmore College, where I teach engineering, but one of the things that I've found in the last few years is that I get a lot of joy from combining my knowledge of computational geometry and computer graphics and motion planning and sort of all kinds of interesting computational reasoning with fabrication and art in the real world. And I think a personal philosophy of mine is that when you get computers to produce tangible things or help you produce tangible things, or make music or things like that in ways that people who don't understand programming can sort of appreciate and interact with, I think that is a really gratifying activity, and in my opinion, sort of the closest I will ever come to doing real magic. So that's kind of why I got into this. So I'm going to talk about a couple different flavors of quilt, one of which you see here, and sort of ways that I have used computation to help me make quilts. So we'll start with this quilt over here, which is an aperiodic tiling. I'm going to start with the definition of nerd sniping. I don't know if anybody has ever heard of nerd sniping, but the idea, it comes from an XKCD, where if you sort of tell a physicist an interesting problem as they're crossing the street, you can actually cause them to get injured in traffic. Right, the idea that there's this problem so interesting, so captivating that you sort of have to drop everything and think about it, even at great personal risk. So I too was nerd sniped by my brother. It was the start of COVID, and we had all gotten into sewing a little bit because we were making masks at home. Do you remember making masks at home? Did some of you do that? And so we were starting to do some more sewing, and my brother said, I wonder if it would be possible to sew a Penrose tiling quilt. And so for those of you who don't know, Penrose tiling is named for this guy, Sir Roger Penrose, which is sort of one of the first known and most popular instances of aperiodic tiling. And it has only two shapes in it that have a certain recipe of how they have to be put together. So it has this kite shape and a dart shape, which are the orange things up here are the darts, and the yellow ones are the kites. And a rule for sort of putting them together. And if you put them together according to this rule, it turns out that there is no way to translate, i.e. move the pattern up, down, left, right, and get back to where you started. And that's really different than, say, like a beehive pattern of hexagons, where if you just sort of scroll the whole thing up by one hexagon, you're back to where you started, right? We're really used to infinite patterns that have translational symmetry, and it was kind of shocking to the math community to find out that you can get this pattern that repeats but has no translational symmetry. So there's two flavors of Penrose tiling. There's actually a couple different flavors, but I chose the kite and dart pattern because I thought it looked really visually interesting. And so here's the quilt. You can also see it right there. So I want to talk a little bit about how I made it, some of the challenges of making a quilt like this, and we'll go into some of the details. So there's a really cool way that you can use a computer to make a Penrose tiling pattern, and it relates to shapes that are half kites and half darts. So what you see here is one half kite. So if you mirrored the shape vertically, you would get kind of a sideways pointing kite. And we have these subdivision rules that say I can take a half kite and I can turn a half kite into two half kites and a half dart, and I can take a half dart and I can turn it into one half kite and one half dart. And so here we are, we've iterated it. We started with a half kite, and now we have a whole kite and a half dart, and we just keep recursively applying these rules over and over and over. By the way, the program that I wrote to help me make the quilt was written in Rust. I got really into Rust for a little while, and I got really excited about writing this program in Rust, so that's what it's written in. And so after you subdivide and subdivide and subdivide, after 8 iterations, we get a pattern that's really complicated, and I just sort of like zoomed really far into that pattern and found a snippet that I liked that would work for a square quilt. And one of the constraints was I didn't want my tiles, my half tiles, to be too big, because if they were too big, they would get bigger than a sheet of paper, and I was using paper to help me with fabrication. So that was one of the things that sort of mediated the size. We have this half kite and half dart template. So you can see over in that A1, that is a template that basically shows me a one-to-one scale way for cutting and sewing these things together. I used a process called foundation paper piecing, which is a way of doing quilting that lets you put together fabric very precisely, so you don't actually need to measure a triangle directly on the fabric. You can basically cut straight through the paper and sew straight through the paper, and the paper gets glued to the fabric in a way that's reversible, that basically stabilizes the fabric while you're doing the construction. So otherwise, it would be really, really difficult to get the precision that you would need in the quilt. And so you can basically take these little templates, and each template, an 8.5 by 11 sheet of paper, converts into either a half kite or a half dart. And then you can trim using a rotary cutter, and you can see I'm making like big piles of these things. And then you can start to sew them together into bigger modules as well. So before I talk about these larger modules, I want to draw your attention to a challenge for machine sewing a piece like this. So if you've used a sewing machine before, you probably know that one of the big rules of a sewing machine is that you can join two pieces of fabric together along a straight line or even a slightly curved line. But what is really hard on a sewing machine is when you have like 3 pieces of fabric meeting together in a Y-shaped join. Sewing machines are fabulously bad. So you try really hard to avoid it. At least I have not found a good way in my quilting practice of doing that. And so you have all these joins in here that sort of look like Y-shaped. So how are you going to do this? And just to sort of show you, well, there are some straight seams on this quilt, right? Like there's one where it goes across the entire quilt and there's a straight seam. But there are a bunch of seams that you could choose to sew along that are not straight. So how do you choose the straight ones? And it turns out that you can use this idea of the recursive subdivision that we were talking about before and sort of identify what were those blocks. And it turns out within a block, all of these little blocks are sort of put together into bigger blocks and stitched together, and you can sort of do it additively. Or you can go backwards from where you started and say, where were those modules when we made that composition? So here is all the composition with sort of all the edge pieces that I ended up trimming off, and then you sort of end up recursively subdividing this thing until you're left with the original modules. So we find a bunch of seams, and then we sort of subdivide, and you get this sort of tree of seams with different shaped and sized modules in here. But all of these modules end up being the half kites and half darts that I was talking about at the outset. And then, so the last thing is, now you need to figure out what order you're going to put together all of these pieces together. This large seam here, seam 35, right, that was the root of the tree. That was the sort of the first subdivision, and it ends up being the last seam that you sew. So this is sort of like depth first ordering plus a little bit of tweaking for convenience sake. So the Rust program, it produces for me essentially a big schematic of, here are all of the modules you need to make, and then here are all of the seams that you need to sew between them. And so this is the state of the quilt immediately before sewing that last seam, seam 35, and you can see all of the paper templates that were used to construct this thing. And all of those dots are, I think, different color codings for different sized modules and different numbers. So my paper seams were lined up, labeled the same numbers as that. And then the cat was the constant presence while sewing the quilt. That's Laverne. So that's basically how that one went together. There's a backside. That's the Penrose tiling quilt. I want to tell you about a couple other quilts. These quilts are based on a concept called a parquet deformation. You might have encountered a parquet deformation if you've seen some MC Escher prints. Escher loved these. Craig Kaplan is very active in the computer graphics community. He has a great quote defining parquet deformations. He says they're a kind of spatial animation in the plane, a tiling whose tiles gradually evolve along one or sometimes two dimensions. So here's one example from Kaplan, and here's one example from Escher. So I have my parquet deformation quilt here, which is also here. And I will be sticking around a little bit after the end of the talk. So if you want to come see these in person, you can come find me. So here is my first parquet deformation quilt. And one of the things that I want to call your attention to is it's all pentagons, but the pentagons change shape as you're going from left to right. So if you look at the left side of the image, you have these yellow pentagons pointing right, and then on the right side of the image, you have these yellow pentagons pointing left. And so just to highlight what that looks like for you. Okay, so the central part is based on this very, very old tiling called the chiropentagonal tiling, which is the dual of the snub square tiling, which is one of the semi-regular tilings. If you're a tiling geek, there's all kinds of cool trivia about the chiropentagonal tiling. But you have these pentagons. They have 120-degree angles and 90-degree angles. And I'm going to show you a little demo. I can't live code a quilt, but I can show you a little demo about some of the geometry that underlies this quilt to give you an idea of what's going on in its construction. So among the languages I code in, one of them is GL shading language. There's a great website called Shader Toy for graphics programming. So you basically just start with a square grid. And this is just a regular square lattice. And then you can basically pick a point in every square. And let's just pay attention to the cyan squares, right? So if we look at the cyan square here, like the one my mouse started in, as I move my mouse all over, right, those points are just changing their position within the square. And if I move my mouse up, they go up. If I move my mouse, they go down. But you know, the pink ones are doing the backwards thing, right? If I move my mouse up, the pink points go down. If I move my mouse down, the pink points go up. So you can see there's like 4 90-degree rotations around a central part. And then to get the chiro tiling, what you need to do is you need to connect up these lines, and you just need to drive the point to a very specific location, which I've marked out here in green. So if I hover the mouse right there, you can see I've got that chiro tiling, and then these are pentagons that have 120-degree angles and then 90-degree angles. Now, if I move my mouse to one of these other points, right up here, you can see that I have a bunch of 90-degree angles and a couple 135-degree angles. And when I move it over here, it's the same angles, but they've changed orientation, right? So what we're doing when we're making this parquet deformation is essentially me moving my mouse is choosing the position of some principal point within a cell, right? And then virtually we're just moving the mouse over the space of the quilt itself. And so next step here is we're going to color the tiles in. And then next step here is we're going to do the parquet deformation dance, right? So that's what this looks like here. So you can see that we're just sort of changing the shape gradually over space. So the program to generate this quilt was written in Python, and it outputs a big master plan that looks like this, which I'm looking at while I'm assembling a bunch of pieces. And then it also outputs a bunch of templates for cardstock that we're going to use a different type of paper piecing. That quilt was foundation paper piecing. This quilt uses English paper piecing. So the deal with English paper piecing is you cut out the shape in advance. It's on a stiffer piece of paper, like a cardstock or something like that. And then you glue the fabric around the paper. And now you're not machine sewing, you are hand sewing, and you're trying to sew things up edge to edge. And you can probably make out a little bit of thread in that photo to sort of see how they are hand stitched together. There's a lovely quilting store in New Jersey, and I was asking the kind women who are working there, how do you do it so nobody can see the seams? And they said, well, if you take our English paper piecing course and pay us, we'll tell you. I just haven't had time yet, but I would love to do that. So that is that quilt. It ended up being a pillow. So one of the awesome things about hitting your 40s is you get back pain. And it turns out that it really matters how you sit. So I said, if I need a back pillow, like I want a back pillow that I want to look at. So that's what that one's for. I did one more. That's right here. This is based on the floret pentagonal tiling. And these are also pentagons. These have 4 120-degree angles and 160-degree angle. And in this one, the change, the spatial change, basically again boils down to moving around some principal point. But you can get different sort of kite shapes on one side and rhombus shapes on the other side. And the best composition I found actually made the transition quite abrupt from the center to the right and the left. It's not a very gradual transition when you look at it. And so here is, again, work in progress of just what it looks like to use a glue stick to baste together these little cards. And then once you're done sewing it, you can pop out all the cards. And that's the photo. Having done this a bunch, some concluding thoughts. I think it's really a lot of fun to take the type of graphical work that even Mike was showing off and turn it into something else, right? Like render it into a different, more permanent medium that involves some hand craftsmanship. When you do these paper piecing techniques, you get a lot of control over the final product, which is great if you're a very fussy person, as coders can tend to be. There's a lot of other advantages of computer-assisted quilting. I knew exactly how much fabric I needed to buy from the outset, right? Because getting the area of a polygon is very easy. You can add whatever sort of overages you need for seam allowances and things like that. You can visualize everything. So, I knew what I wanted my quilt to look like before I made it. You can use existing palettes. Smarter people than me have thought about colors that work really well together. So I shamelessly have just stolen from the Matplotlib color plots. And like this is the Viridis quilt, if you guys know Matplotlib Viridis. That made me happy. I would love to teach a course about this. I teach in an engineering program. Every once in a blue moon, I get to teach what we call an outreach course, which is sort of for non-majors, and it's about bringing ideas from engineering into other walks of life. And I think this is a really good way to do that. I absolutely believe that quilting is engineering if you want it to be. So I worked with a summer student one summer to see what it would look like to transfer this model over to a student. So Mike Melnikoff did some really great work with me. He made a little quilt, and then he made a design for a much bigger quilt that was a parquet deformation of his own creation that I would love to see in real life, but then his tennis schedule got really busy and he wasn't actually able to finish the quilt. But that is what I have for you, and I'm happy to take your questions.
Thank you, Michael.
So in the vein of the last presentation also, and maybe I missed this in the parquet deformations, is there any work being done on like functions of functions in the transformation?
Yeah, I mean, so yes, so the Shader Toy website that I was at before is shader coding or fragment shader coding. There is a live coding scene for fragment shader coding, and the people who are very successful in that space are really good at thinking about efficient ways to encode how to produce a particular pattern, right? And one of the things that they are very good at is figuring out how to add the types of parameters that the previous two presenters were talking about in ways such that you can kind of tweak them programmatically. Matthew was talking about like adding randomness, which is like, yes, graphics programmers love noise primitives for all kinds of these reasons. And once you have the ability to sort of iteratively put down patterns in different ways in different places, finding different functions to guide that sort of is the whole game.
To what extent is this reversible? So let's say I gave you a quilt like that, and I asked, can you come up with a compact representation that would produce that quilt in one of these languages? How feasible is that?
I mean, I think one of the big revelations for me on this project is that the plan is maybe like 10% of the work, right? And this is a difference between the purely digital domain and the material world that we live in. And even sitting at the sewing machine, that's not most of your time. Most of your time on a project like this is spent cutting things out and measuring things and pinning things together. And so, if you want to talk about what is the most concise program to do this, or if you want to talk about sort of what is the briefest representation, like, we can talk about that. And what it turns out is that the more time you pour in to making something that is an act of communication, the better it is. So I have a good friend who's an engineer, and he says that people misunderstand CAD. People think that CAD, computer-aided design, like, Autodesk, Inventor, CAD is going to spit out a file that you can like 3D print or send to a manufacturer. And so people think that like when you're doing CAD, you're designing the part. He says that's absolutely not true. CAD is an act of communication. CAD is telling somebody else how the part is made and what are the important parts about that. And so to answer your question, I would say I could write a very short program to make that image, and it would tell you very little about how to make that quilt. And so there's a continuum, and where you want to be on that continuum depends on sort of what is your practice and what you want to do once you have the image. I hope that's a help.
Hey, sorry. Wanna go? Yeah, I was just wondering. I've never sewed before, but have you found it easier to take those primitive shapes and then, like, for joining the edges, like extending it from the shape outside and then, like, I don't know, overlapping them, or having the edges like within the shapes itself, like from the beginning?
Yeah. Having done both, I mean, so foundation paper piecing is sort of like you start out by making a shape that's too big and then building in the seam allowance. English paper piecing is you're sewing exactly the shape. They're both good for different things. If you're making a quilt that's all hexagons, you have to use English paper piecing because of all of the Y seams, right? And so it just sort of depends on what the geometry tells you to do. The other thing is these techniques are really old. They go back to the 1600s and 1700s. So, I'm trailblazing in some ways by saying like, yeah, let's point computers at this novel thing. And then also, I really want to respect the people who have been doing this for literal centuries because they know better than I the ways of making fabric sort of combine well together.
Hi. First, you should definitely submit these to the quilt show that happens every December in West Philly. They're awesome. And secondly, my question is, with foundation paper piecing, when do you remove the paper? Do you do it after sewing, or is it dissolvable?
Yeah, so I remove the paper. You make a center. You get the entire thing sewn together. And then before you do the quilting, before you make the sandwich and like sew all the layers together, that's when you take the paper off. People have different ways of doing it. There is like specialized, sometimes people use glue that's called like basting glue that's like designed for this. I just use Elmer's glue stick and regular office paper. Like you can use, no, actually I use foundation paper. But like there's 18 gazillion ways of doing this, and people on the internet have their own best ways of doing it. But yeah, I just used foundation paper that I bought online. I used Elmer's glue, and it worked well enough. And if you took that quilt apart, you would probably find in the deep seams where you have like at a point, right? Like there are tiny scraps of paper in there, and that's fine.
Hi, that's awesome. So much of like coding and development is built around this idea of the iteration loop and the fast iteration loop. And given that you've approached such a beautifully slow iteration loop, how do you find your experience of time with the actual fabrication? Does that change your relationship to the algorithms, to the computer process?
Yeah.
Do you want, do you come away wanting to change an algorithm, or are you so like satisfied with it after?
Yeah, no, that's a great question. doing physical crafts, especially textile crafts, is slow. And you just need to get in that mindset, right? That I think everybody who sews a lot knows that actually the minority of your time is spent sewing at the sewing machine, right? Like most of the time you're measuring, pinning, cutting, whatever, right? Like your setup time completely dominates your machine time, just like in the machine shop, right? And so if that is the attitude that you sort of go in with, yeah, prototyping's fun. It's slow. It's a very different pace. So what I did not show you is like the 14 crappy prototypes I made, as I was learning how to English paper piece. Before that, I had this idea about like CNC cut templates in kite and dart shapes. And so, yeah, there was a ton of prototyping that went into all of this. Little studies, little color studies, little, I'm going to just sew together like 5 tiles to see if it works. And you do it, and you still have to do it, and it's slow, and it just unfolds over a much different time scale. And I think it encourages like a lot of deliberative thought about this. I think I have co-taught with a studio art professor course, design and sculpture in the digital age. And we had students using computer-assisted design programs to like solve cool design problems with 3D printers and laser cutters. And we really wanted to insert some friction in front of the immediacy of a CAD tool. Because when you're just sitting in front of the computer and you can make any shape you want, you kind of get into a flow state about just sort of going where the program's affordances nudge you, and not about sort of making something coherent and intentional. And I think having that physical fabrication component where, yeah, you just gotta like do really slowly and make it, like that invites a different approach to composition that I value.
Any other questions? Okay, well, thank you again.
Thanks, everybody.